So the first type we were discussing about the transmission media. We were discussing guided and unguided media, and the first one guided medium, that means the physical one. The first one we discuss under twisted pair. We will talk about the unshielded twisted pair cable, UTP in short, and then Cat1, Cat5, Cat6, some examples. And the second one we call shielded twisted pair. Now, in shielded twisted pair, what we have is we have an outer cover. You have an outer cover is added. The reason for adding outer cover is for better quality and security, right? So let's take down the shielded twisted pair, or we call STP in short, right? Outer cover is added for the ordinary twisted pair cable, right? This provides better quality and secure transmission, right? Make a note of this. Right. The next one we are going to talk about is coaxial cables. Okay, let me show you an image of shielded twisted pair. Right. So when you say shielded twisted pair, so you can see uh, what we have. Let me copy image. So you can see unshielded means we have simply outer cover, but then you have these twisted pair cables. But then in shielded ones, we have a special cover for this, right? And this is much better, and it's expensive as well, right? So this is for better the transmission. Okay, the next one we are going to talk about is coaxial cable, which you can see here. For example, right. So for example, if you can look at coaxial in TV cables, for example, the term coaxial means so there will be two cables, surrounding cables. Maybe we'll draw a small figure, coaxial cable, because let's write coaxial cable. And then let's draw this. So let's draw this figure. because this will give you an idea of how this works. So outside one is here. In the middle, we have the copper wire. And then we have some insulation material where it separates this copper wire from the outside. Then you have a copper mesh, right? The real picture look like this. So this is the drawing, right? So in a real picture, look like this, something like this, right? Draw this one. Once you finish, let me know. So let's write down about the coaxial cable. The cable consists of inner copper cable. So this is the one, surrounded by a copper net or mesh. So this is the other one. The two cables separated by a shield, the insulation. So the separation by insulation, and this is the outcome. So the examples are, we have TV, antenna cables, and CCTV. Right. So the features we can say, handles noise successfully, transmit data longer distances at higher speed, used for both analog and digital signals. Right. So in fiber optics, they are the fastest as well as the expensive cables. And fiber optics usually use uh, the light for data transmission, right? So when you look at fiber optic cable, um, we will use, let's write down fiber optic cable. We can say fiber optic cables use light for data transmission. And the features, let's write down the features. Now, first one, you have a high bandwidth, right? You have high bandwidth, which means you can send a lot of data transmission. Okay, right. You have high bandwidth, and therefore it's expensive because it use a lot of other material. We are not going to see how it look like, but you have a couple of things are there. So for example, if I show you an image, right, of fiber optics. So usually I told you it's use data. That means the cable is what's inside it, the glass cable, glass core we call it. And then we have a shield, then you have a plastic cover, and then finally outer jacket, which means it's quite expensive cable. Right. So what we have discussed so far is guided media. Let's look at unguided or wireless media, right? So what we have discussed is guided. So let's look at unguided transmission media. Let's write down. Unguided or wireless. Sometimes we call wireless transmission media. Right. So when you say unguided media, we are going to talk about a couple of things. The first one, the transmission happen through signals in air without a physical medium. So we can say it's transmitted as signals through air without physical medium. That is the first thing we need to discuss. So there's no physical medium involved here. Right. Couple of things we can talk about this. So the first one, under this one, we can talk about radio waves. Radio waves. So under radio waves, we can say this is used in radio and television communication. Example, Wi-Fi, Bluetooth. Right. Then shorter ones we can use. Um, that is what we call microwaves. So the next one we can talk about microwaves. So microwaves, again, what we have very short wavelengths. You can say radio waves. They are the same radio waves, but with very short wavelengths. And are used for satellite television transmission and transmission of telephone signals. Further, microwaves are used in satellite communication. Using this method, data can be transmitted to any distance. Right. Let's write down. Right. The next one, we have what we call infrared. Infrared. Infrared is usually you can see these kind of waves in TV remotes, wireless keyboards, mouse, and even in printers, right? So this is possible. So let's write down that. So used in wireless keyboards, mouse, uh, printers, and television remote controls. Right. Now that we have discussed the three, we can look at why, you can compare if you want. So the few things to note, the radio waves is um, and microwave, infrared, there are differences. Now, for example, if you look at the frequencies, frequency ranges are different. Security is different. For example, radio waves, it's poor security, but the microwave, you have medium security, and infrared, you have high security, and so on. So these are like some of the properties of these three. But I think we are not really interested at this level. We are not going to talk about all these details. අපි හැමදේම කතා කරමු. මේ වල වෙනස්කම් තියෙනවා පොතේ තුන් වර්ග තුනේම. සාමාන්‍ය මේ ටික ඔයගොල්ලෝ දැනගත්තාම ඇති. Right. Okay, so what we were using is the transmission media. So let's move on to the properties, right? So we can say properties of these transmission media, right? So when you talk about the properties, we are going to talk about things like latency, bandwidth, noise, attenuation, distortion, and so on. So let's look at what those are. So let's have a subtopic once we have finished this one. So let's look at, okay, let's type in properties. Properties of signal. Signal transmission media. Right. So let's look at some properties of these. Right. Okay. A few things we are going to look at about these. As I told you earlier that we are going to look at, or we can say signal property. I think we'll put, yeah. So the first thing that we are going to discuss, so under properties, is latency. Let's write down latency. Or in other words, we call delay. Right. First of all, latency and delay. Now, when you say a latency, it means, first of all, sending data from one place to another place, right? Then when you're sending data from one place to another place, right, there will be a time taken for this. Now, for example, if you take a data transmission in a network, you are sending data from one place to another place. It will take some time. So this time, the delay, we normally called latency. So usually when you measure this delay, we use in microseconds, right? You see sometimes when we want to check our networking speeds in computers, you see they show some delay. Delay means we go from our computer to the server computer and we are coming back. The time taken for this, we call latency. So the travel time from our computer to the server and coming back, we call latency. Right now, let me show you an image for this. Right? So this is, one example. You don't have to draw this, right? But just to show you like what latency means. So we can say the latency is the time taken for a unit of data to travel from one point to another. So this is called latency. So let's write down the unit which is used to measure latency is milliseconds used in MS. So you can see even in the figure, when sometimes when you want to access some data from a server in the internet, it will take some time. So you can see in this example, So to go to the server, it took about like 250. To get back the data, it took about 300 milliseconds. And altogether, the total time it taken is 550. So usually we say, okay, latency is 550 milliseconds. That is what we call latency. So let me explain this with an image like in early. Again, you don't have to take down this image, right? Now bandwidth means something like this. So let's say we have a small narrow path and then there were some cars going on. Now what happens when you measure, since this is limited, right? We might get a one car uh, per second. So we can say the data bandwidth is, you know, uh, one data packet per second, like assuming that this packet. Now let's say you have a wide bandwidth. That means instead of one car passing through this, you can have in parallel, you can have 5 cars. So we can say bandwidth is high. So in simple terms, the bandwidth means uh, we can have how much data you can transmit for a given path, right? How much data we can transmit. So simply, it's the range of frequencies that you can have within this one. So we will measure this in bits per second, right? Okay, so let's write down. So simply, we can say the idea of bandwidth is, right? We can say in data communication, we can say bandwidth is the range of frequencies and measured in hertz. So in computing, we can say the same thing. Now bandwidth is used to refer the amount of data transfer across a given path. Now you know that the range of frequencies, if you can have higher range, then we can say we have a higher bandwidth. In data, we say, okay, the amount of data you can transmit is very high. Right. Now, this is measured in BPS or bits per second, for example, in computing. So other measurements include, we can have kilobits per second, megabits per second, and gigabits per second. So this, when it comes to computers, in communication, we usually use hertz. Next one, we are going to talk about noise in signals. Now, noise means when you are sending data, there are some data which is not relevant for this, which we call noise. So sometimes we call thermal noise, induced noise, crosstalk noise. There are different types of noise, right? So the noise actually harm of the data transmission. So we need to send something, but there are some additional uh, 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 additional noise, additional signals come in to transmitted signals. So for example, let me show you an image for this one as well. So when I say, for example, like this, here you can see we have, right? So when, let's say, we want to transmit some signal like this, so this is what we want to say. But when we are trying to send this signal from this point to the other point, so some other signal mixed with what we are sending here, and what we are receiving is a signal with noise, right? So this is what we call the noise, right? So let's write down. So under noise, the signal relevant to data is transmitted with data transmitted with the signal relevant to data is transmitted with signal relevant to background, which is not important. External, right? So that is exactly what I want to tell here. So we have something to send, but you send with both. This is noise. The signal which is not the one is called noise. And there are different types. There are different types of, there are different types. We'll say several types. There are several types, such as thermal noise, induced noise, crosstalk noise, and impulse noise, and so on. Right. So the next one we are going to talk about is attenuation. Attenuation means when you transmit a signal, the strength decreases when you transmit, right? Signal එකක් අපි යවද්දි ඒකේ strength එක එන්නේ අඩු වෙනවා. So this is what exactly happens usually when you're transmitting a signal. distance එක වැඩි වෙන දෙයද මේ signal එකේ strength එක අඩු වෙනවා. ඒක හින්දා තමයි සමහර වෙලාවට අපි repeaters පාවිච්චි කරන්නේ. right? අපි ඒකට පොඩි graph එකක් ඇඳගෙන ඉමු. So let's draw this one. Signal එකත් එක්ක. So let's draw this right. draw කරගන්න පොතේ මේක මේ මෙහෙම තියෙන signal එකක් මේක time එක අපි හිතමු මේ තියෙන voltage එක කියලා මෙහෙම voltage එක වෙනස් වෙනවා sine wave එකක් වගේ හැබැයි ඒක transmit කරද්දී අතට මේ pattern එක transmit කරද්දී මොකද වෙන්නේ දුරට යද්දී මේ strength එකේ එන්න අඩු වෙනවා. So let's write down. We can say the reduction of signal strength when it transmit through a given medium. So that is what we call attenuation. So we can say the to prevent attenuation, we can use amplifiers. අපිට මේක amplify කරන්න පුළුවන්. Again, just to show you an image. Again, you don't have to take down this, right? So what normally happens when data transmitted, right? The signal strength is, similar to this, then we can amplify, increase. Right? Now it'll be similar to the origin. So that is what we call amplification. Right. Now let's move on to the next topic. So the next topic is distortion. Distortion. Now, distortion means that the signal, the shape might change. Now, for example, if you have original signals, when you change, the shape will be different, right? Due to various reasons. There are multiple reasons this could happen. So the distortion is the shape will be different. Right, let's write down. Distortion, the properties of the original signal may change during the transmission due to various reasons, but let's say the common ones are capacitance and the inductance. Of the communication medium. This is called distortion. So you can see in this example, for example, we have some signal. Make another command. Let's take down this one. Right. We can draw like this. The shape will change due to various reasons. Capacitance and induction means the effects of in copper cables usually will affects the change of the signal. So when you're sending a signal, it look like this, but when you're receiving, it's something like this, right? And this is called distortion. Right. So we were we were discussing signal properties, and the last one we discussed um about the distortion. So the distortion means uh, going with the when we are sending a signal, the shape will be changed due to various factors. And for example, I told you in copper cables, when you send signals, the shape will be, distorted like this. Right. The last thing that we are going to discuss, we call uh, it's a separate one. Now, for example, simple topology. So simple topology means connecting devices. Let's draw this one. So simply we can say connecting two devices such as computer, hub, switch, routers, servers using a single cable is known as point to point connection. Point to point connection. Right. With this one, we actually finish 6.1, that is the basics part, and 6.2, the transmission medium. Right. So next we are moving on to new topic. Let me know when you're finished. Finished? Okay, right. So this is the next one. That means 6.3, the next section we are going to discuss. So in this part, we are going to discuss uh, what we call the data encoding, right? And uses signals. Now, when you say, how do you encode, right? And how do you graphically represent? Then we are going to talk about how frequency and phases, which we have discussed earlier, how we can use them, how to synchronize them, and what are the problems, and what are the ways that we can actually handle the equation. Right. So let's start. 6.3. Let's write down the topic. Data encoding. Using signal elements. Right. Data encoding uses signal elements. Now, before we talk about the encoding, we know a couple of terms. The first term that we are going to use is called modulation. Now, modulation means when you want to send a signal from one place to another, you have to use some other signal. This is what we call carrier signal. And then only you are going to use this, right? So let's see. What we have is modulation, right? So we have to convert, or we have to use another, right? When you want to transmit, we have to use. So simply we can say it's we are going to change. We are converting signals into something else for the sake of transmission. So let's write down. The first thing that I'm going to talk about under this is called modulation. So let's talk about modulation. Right. So when we say modulation, right, we can say to send data from one point to another, the signal modulating signal, that means what we want to say, right? We have to use with another signal we call higher frequency signal, we call carrier signal. Now, how do you do this? By using frequency, amplitude, and phase. Let's see how we are going to do this. By modify frequency, amplitude, and phase. Right. And that is exactly what we are going to do next. So I told you, like, when you want to send data from one point, we are sending it as a signal. And we need some other signal to send this. So let's look at the first technique under this. So the first one under this one is called amplitude modulation. So the first one we call amplitude modulation. Or in short, we will say AM. Right. So let's write it down. Now, when you say amplitude, it's the height of the signal. Remember, we discussed these properties earlier. Amplitude, that is height of the signal of carrier signal, varies according to the amplitude of the modulating signal. Modulating signal. The frequency phase of the carrier signal remains unchanged. Right. Let me explain. Now, when you say amplitude modulation, we are going to look at the height, but height will change according to the carrier signal. So let me show you a figure which uses this idea. Right. Uh, so let me show you the figure first. Now it's like this. So let's say this is the signal, and you can see the height is the amplitude, and this is what we want to send. Now I told you the reason, there are a couple of reasons why we are doing this. When you want to send, we will use some other signal, right? We will use some other signal to send this. And that some other signal we call carrier signal. So this is called carrier signal. So this is called carrier signal. So we will have like this, and then we will have a carrier signal, and we combine the two. Now when we are combining, this one we use to represent this message signal. So what happens? According to this, you can see it will increases. And this is what we are going to say, right? So this is the original one. This is another one we are going to mix it. When you mix it, you get the height. So whenever, for example, this is the highest position, it will add it to this signal, and the size will be increased. discuss some advantages and disadvantages of amplitude modulation. So as you can see, we are going to consider the height of the signal. So let's write down the advantages of this technique. The first of all, you can say modulation is easy. Why modulation is easy? We are just adding the two signals together. We take the height of the signal, we just add them. Now, the next one is, now this is called modulation, which means we combine the signal. When you want to separate the signal, we call demodulation. So this is also easy. Modulation and demodulation both are easy. So we can say demodulation can be done using a simple circuit. Right. Then disadvantages. So the disadvantage is maybe affected by external noises. Affected, let me say, affected by some noise elements can be added, which might cause problems. So the second one, as we discussed, it's called frequency modulation. So in frequency modulation, what happens? We take the frequency of the message and frequency carrier is combined along the frequency. And then we'll get modulated signal. Right. To discuss, we want to discuss next advantages and disadvantages of this technique. So advantages are, the first one, the effect of noise is reduced in this technique compared to others. And then this, using this one, ability to transmit clear sound. You can send sound clearly. Disadvantages, circuits used for modulation and demodulation is very complex. High cost for modulation and demodulation. Okay? So these are the advantages and disadvantages. Okay, then. With that one, we can finish for today.